Hi, and welcome to the fourth of 4 videos for section 3.2. As I alluded to at the end of the third video, we're going to be looking at something called multiplicity. And here's the definition. If C is a zero of P, polynomial function, and occurs m times, then we say C is a zero with multiplicity m. Once we know that, if m is odd, so if m is 1, 3, 5, 7, 9, etc., then the graph crosses the x-axis, and if m is even, so if that root occurs 2, 4, 6, 8, etc. times, even the graph does not cross this should be x-axis. Does not cross the x-axis. And it does, so it does, if it's an odd, it does cross the x-axis. If it's even, it does not cross the x-axis. So if you remember to that example at the end of last video, video 3, we had what? We had a graph that looked like this, remember? And it's because when we factored out, we had x squared, well actually negative x squared, and then 2 other factors. But because this x squared, it means that this root, which was x equals 0, had multiplicity of 2. It occurred 2 times. So because m is even, it was 2, the graph does not cross the x-axis. And in fact, what I like to say is it bounces. So it comes down to the graph and bounces off. Or if it's coming from below, it bounces off the x-axis and comes back down. So if multiplicity is even, the graph doesn't cross. What it does is it bounces off the x-axis. So let's look at an example. Let's sketch p of x is equal to x to the 4th times x minus 2 to the 3rd times x plus 1 squared. So again, make the use of these videos. Hit pause. Try to figure out what's my x-intercepts, what's my y-intercepts, or what's my roots, what's my y-intercepts, what's the end behavior. And now that we have this idea of multiplicity, does it cross the x-axis or does it bounce off the x-axis? So go ahead and hit pause, try that, and come on back. All right, welcome back. So, we have what? We have x to the 4th is 0. And I'm really just worried about what's inside of, so actually, I don't even need the x to the 4th there. I'm just worried about what's inside the parenthesis pieces, setting that equal to 0. So x is 0, x minus 2 is 0, x plus 1 is 0. So that means x is 0 is one of my roots, x is positive 2 is the other root, x minus 3 is my 3rd root. So now I'm going to use this idea of multiplicity. X to the 4th, that's even, so that means what? When x is 0, it's bouncing, so let me write down multiplicity 4. So m is equal to 4, my multiplicity, so it's bouncing. X minus 2, that's m, is equal to 3. That's an odd, so that means it crosses the x-axis at x equals 2. And at x equals -1, my multiplicity is 2. Again, that's even, so it's bouncing off of this point as well. So that was part 1. Part 2, p of 0. Well, this is going to be some number, that's going to be some number, but in the front here I have 0 to the 4th. 0 to the 4th is 0 times everything else means that this is still 0. And then end behavior. So what do I have? To figure out the degree of this polynomial, it's what? 4 plus 3 plus 2. So 4 plus 3 plus 2 is 7 is 9. So that means it's an odd degree polynomial. If you multiplied this whole thing out, you would end up with x to the 9th plus a bunch of garbage. Don't worry about it. The main thing is that first term, the highest degree, which has degree 9. Because this is positive, that's positive, that's positive, it means that it's an odd degree polynomial with positive. So we know that that means the end behavior looks like what? It looks like our x to the 3rd graph, which is going up to the right and going down to the left. So now, if I'm going to sketch this thing, so my zeros are at what? 0. So focus on this one, not the m's. We want this line here. So maybe on when you're taking an exam, box that in so that you know which ones are your zeros. So 0, 2, and -1. Our y-intercept, the origin, we already have a point there. And our end behavior is starting up here, ending down here. So I'm going to work from left to right. So as I come to the left, the first point I hit is -1. That's bouncing. So it doesn't cross, it just bounces and comes back down. Keep moving over to the right, I hit 0. That's another bounce. So it turns around, bounces back. And then at x equals 2, it's telling me to cross through. So you should probably have something that looks like that. So that's what your sketch should look like, but now we have one last piece to add in about this idea of multiplicity and the way that the graph acts at these points. So let me see here. I'm going to erase this, the 2 and 3. I want to leave this other information up here right now. Let me change pen color so you get this part as the notes though. So, one last piece to add about multiplicity, and that's the following. If C is a 0 of multiplicity m, then the shape of the graph of P near C, my 0, is as follows. So, if m is odd and m is greater than 1, so if multiplicity is 3 or 5 or 7 or 9, etc., then we have the graph that looks like this. So at my point C, So if m is odd and m is greater than or equal to 1, it's going to look like this. It doesn't, in fact, so if m is 3, 5, 7, 9, etc., it doesn't just cross straight through, it does what I call snakes through. So it flattens off, goes through the point, and then continues on. Or, depending on which way the end behavior is, it could also be flipped the other way. So it could be coming down from the left, flattens out, and then continues on down to the right. But the point being is that I'm going to call it here, so we had crossing, we had bouncing, and we're now going to call this snakes. It snakes through. It levels off and then continues again, kind of like a snake slithering through. So if that's the case, if that's our new information, and that's why I wanted to leave this up here, if we go back to this graph that we just sketched, because multiplicity is 3, it doesn't really cross through, it snakes through. So the correct way that this graph should look is that my point is at x equals 2 where it snakes through. So as it's coming around here, it kind of levels off and then continues up again. So it doesn't just run straight through like I had originally drawn it intentionally, but it comes up, levels off, and then continues on. So this is really what this sketch of this polynomial should look like. And then one last little bit of information as far as this section goes. And we talked a little bit about it when we were talking about increasing functions, decreasing functions, and so forth. And that's our local max and local min. So just as a reminder, a local maxima and minima, or minimum. So if I have some curve, some polynomial function here, this point here, if it occurs at my x is equal to a, this point is a, and then whatever the function value of a is. And that would be the local maxima. If I just look at a little part of this, that's the highest point, so that's local maximum. Maxima is plural, so you could have a few of them. And then similarly, if this is a point b, x equals b, whatever that value is, this minimum point here occurs at b, and then f of b. So if this is 10, if I plug 10 into the function, that gives me the numerical value of the function at that point. So that's it. Like I sort of told you at the start, 3-2, a little bit longer, but it's all these different pieces that as we put it together allows us to sketch something like this, which I would, hopefully you feel like that's a pretty impressive thing now that you can sketch that pretty awful looking polynomial function. So come on back, that's the end of 3-2. We'll start looking at the videos for section 3-3.